Good afternoon, students. I'm Ms. Josephine Shangula, your tutor for learning support in mathematics. So I'm going to carry you through for exam-based contact class lessons. Let's start off with the instructions. These are the common used instructions for exams, and I would like you to be very much aware and to take note before you start with your examination, before you start answering anything on your paper. Please study your instructions thoroughly. Number one, answer all the questions for 100 marks on the question paper. Remember, your LSM32 totals 100 marks. So whatever you answer, go through your paper and make sure you have answered enough for 100 marks. Use the mark allocation for each question as guide for how many facts are needed. Most of you have a tendency of shortening your answers. I don't know if it's laziness or whatever, but please take note. Your mark allocated at the end of each question is supposed to guide you as to how many facts to answer per question. Next, observe the thinking level of the verb. There are still a few students who do not take verbs seriously, whereby they start listing instead of explaining something, for instance. So please, you must observe the thinking level of that verb before you answer the question. Although you may know the content, try to understand and know what verb is used in that question. Number your work correctly. I believe we are all very much skilled when it comes to numbering our work at this stage. And then lastly, neat and tidy work is required. Let's move on. Verbs used in the examination. These are just a few of the verbs that you may come across in the question paper, but please, your study guides have verbs at the beginning of it. Study them thoroughly. However, the following 6 are the commonly used verbs. Number one, discuss. Means to write about something in detail, taking into account different issues or ideas. You are discussing something, so you go into detail about whatever you are asked to describe or to discuss. The next verb is describe, to report details about something, more or less similar to discussing. You must give a report in detail about whatever you are asked to describe. The next one is explain. Explain means to make or an idea or situation clear to someone by describing it in more detail, revealing facts. Let it be characteristics, any description that you can come across, whatever facts you can come across regarding the content that you're trying to answer. Please, when we say explain, make it as clear as possible by describing again in detail. So the above 3 verbs are more or less the same. They are more or less about explaining something, but take into account that you are doing it in detail. The next one is differentiate, to show or find the difference between things that are compared. You differentiate between 2 or more things. Give differences. Each one, you describing it or you explain it, what makes it different from the other that you are comparing it with. Then we move on to clarify. Here we are giving something very in simplest terms. You are trying to make it as clear as possible, to make something more clear or easier to understand. Meaning you try to give it in your simplest words, in your simplest terms, very, very clear and easier for anyone to understand. The next verb is evaluate. Evaluate means to form an opinion of the amount, value, or quality of something after thinking about it carefully. Before you evaluate something, you think about it carefully, you think thoroughly. That's when you give your own opinion, depending on the amount of value or quality of whatever that you are asked to evaluate. We move on. The following is it's a summary of what is in your study guide. Most of you you choose what you want to study, although you may not know what might be covered in the exam. So what I did here is I just go through your whole study guide, pick up a few things from your competencies, and then I made a summary Please, this is not a question paper. It is not an assignment. It's just a summary of your content. The areas that most students experience problems with is what I try to summarize here. Go through your whole study guides when you are preparing for an exam. Do not limit yourself with what I'm going to provide you. Let's start with learning processes. We have 4 learning processes. The awareness. For each learning process student, don't just learn how to define a learning process. Go beyond and see how you as a teacher can do to facilitate this learning process stage. These are the 4 stages that we have. What can you as a teacher do to facilitate this stage? Let's look at awareness. During the awareness stage, children begin to notice and become interested. Now, in order to facilitate this stage, what can you do as a teacher to be able to assist learners to go through this awareness stage? It says teachers should firstly provide an environment with many stimuli to promote interest, and secondly, when children show an interest, teachers should encourage this interest and encourage children to explore the interest. So take note of your students' interests. Encourage them. Try to study their interests, because this is a very important stage for a learner to learn about anything. These are learning processes. So the first stage is the awareness stage. And we say here learners, they begin to notice and they become interested. You as a teacher, try to make the environment as conducive as possible by being interested in their whatever they try to in all their interests, whatever they have interest in. Try to be very much interested in that as well, because through that you are actually encouraging their interest. Next stage is the exploration. During the exploration stage, children begin to investigate something that has caught their attention. They begin to discover and explore in order to make sense and meaning of the object or situation. You put a learner in a certain situation. What this learner do at this stage of exploration, they discover. They want to make sense of that situation, so they explore. That's the only way they will be able to explore or make sense of that situation that they may find themselves. Now, facilitation from you as a teacher. What can you do to facilitate? Teachers should encourage exploration. Again, we repeat, encouragement. These are learning processes. So you as a teacher, you also have a responsibility here and there. And ask open-ended questions to broaden and expand the child's exploration. The child is exploring. What do you do as a teacher? You ask those open-ended questions. It gives the child time to think. They've explored something, but try to broaden their exploration stage. For example, teachers could ask questions such as, what else can you see? Meaning a child has seen something. Now you want this child to explore further than that and give an open-ended question. What else can you see? This child will think. Or what happens when you fold the paper again? The paper has been folded. Now you want the child to go out of, there was awareness stage. Now the child must explore, like what happens after then? If I fold this paper again, what happens? This is an open-ended question, and this child will give their own description. We move on to the third stage, which is the inquiry stage. During this stage, children begin to make sense of a concept. They relate what they are exploring to knowledge they already have and try to form a generalization. Here they are inquiring. They have to make sense of that concept that they have now explored. So they have to inquire, relate it to something that they already know. It's not something new. They have to relate to that knowledge that they already have. In order for a teacher to facilitate the meaning-making process of inquiry, in this stage, teachers should attempt to guide children to the understanding and internalizing of the particular concept by asking more leading questions. You must provide leading on questions because this child is trying to inquire what they've explored to what they have already know. Last stage is the utilization. It says during this stage, children are able to transfer knowledge from one concept to another. Teachers can help to do this by making sure children are aware of the general properties of a concept. For example, after a lesson on rectangles, the teacher could ask learners to identify all the rectangles in the classroom. You gave your lesson on rectangles. Now, you want to test their knowledge. They have to transfer this knowledge from one concept to another concept. So what do you do? Based on what you have taught them on your lesson of rectangles, you ask them, what else? What other rectangles can you see around us? They look around and then they use what they've learned by identifying any object that is in a form of a rectangle. Example, window, door, board. And then ask children to find 3 examples of rectangles at home and tell the class the next day what they found at home that is in the shape of a rectangle. So here they are transferring their knowledge of one concept to another concept. We call this utilization stage. All these 4 are our learning processes. We do not need only to know what they are. We need to know as teachers how we can apply them. Let's move on to our next topic, which is the convergent thinking questions and the divergent thinking questions. What is the difference between the 2 thinking questions? It says convergent thinking questions require convergent thinking and use a higher level of memory than recall questions. A learner has to combine given and remembered information to come to an answer. Remember, for a child, given that convergent question, a child will have to be given something that this child can combine with what the child has to remember in order to get to that answer. Answers are often found by carrying out learned procedures, learned already. All convergent thinking questions are about learning facts, follow instructions, and solving problems with one right answer. Meaning convergent thinking questions have one right answer. You have to be provided with something, link it to what you remember, what you have already learned. You combine the 2 for you to get to an answer. Know the difference. With the convergent thinking questions, one thing we should not forget is that you follow instructions. You are given an instruction to follow. Let's look at the divergent thinking questions. First, let's look at this example. Let's have a look at this example for a convergent. If the radius of a circle is 5 centimeters, find the area of the circle. That's a convergent thinking question. You are provided with the radius already. Now find the area. You are given information. Remember formulas or area for you to be able to apply to get to the answer. That's what we mean by convergent. Now, divergent thinking questions, however, it promotes divergent thinking. These questions are open or general and promote discussion. Unlike convergent, these ones are general and they are open, meaning your answers can be different. Unlike convergent, where there is a specific answer. This one, they promote discussion because it's an open questions, so you discuss the answer. Learners are required to be original and to think for themselves. Learners need to organize ideas and to infer and predict in order to reach an answer. There are various possibilities in response. As I say, there's more than one correct answer. There are various possibilities in response. Because it's discussion, it's open for discussion. You give your opinion, your view. For example, an example of a divergent thinking question is, describe a situation besides a school where mathematics is applied in your everyday life. It's a general question. It's open for discussion. It promotes thinking. You know, you have to be original. You have to think for yourself that apart from school, where else is mathematics applied? You are thinking, you are discussing. So I want you to understand fully the differences between, not just as to how to define them on paper, but practically examples, proper examples of the convergent and the divergent thinking questions. We move on. The difference between cardinal and ordinal numbers. We are all very much familiar with this one. Cardinal numbers, an example 1, 2, 3, 4, specify the size of a set. Remember, size of a set. The last number you say when counting them is the number of the objects in the set. So if your last number is 15, meaning there are 15 objects in that set, that's what we mean by specify the size of a set. Ordinal numbers, however, are like first. This is spelling error there, sorry for that. Second, third, fourth. These specify the position of an object in a set. Here we are specifying the position. It does not mean if you count up to 7th, there are 7 objects in a set. No. It's only specifying its position. Is 7th out of maybe 15th. Let's move on. Graphs are useful tools for representing data. Why are graphs useful when it comes to representing information? There are 3 points here. Graphs display findings in a visual format. Visual means you can see. You understand by seeing the graph. Displaying data visually makes it easier to identify trends and make comparisons simply by looking at the graph. If you have a graph of different colors, just by looking at the trend, you can see that which color is commonly used or is commonly favored compared to the other color. That's what we mean by it makes it easy to identify trends. You can see when it's coming down, which one is higher, which one is lower. The third point is a lot of information can be condensed into one graph. Just one simple graph can have different information. The number of learners versus their favorite ice cream, for instance, or flavors of ice creams. So in that one simple bar graph, whatever type of graph, you can have a number of learners up to 30 or whatever number depending on your access labeling. So this is what we mean by a lot of information. It can be condensed just into one graph. One graph can consist of so much information. Next, we have the 2 types of assessments, the summative and the formative assessment. Summative assessment is usually done at the end of the year or semester. It usually sums up what the learners have done through the whole course. It's a summary of everything that you have done. Summative assessment takes place after the learning has been completed and provides information and feedback that sums up the teaching and learning processes. So in just this paragraph, I see 2 things. I see a definition of summative assessment. It's done at the end of the year or semester. It sums up what the learners have done throughout the whole course. It takes place after the learning has been completed. Now, what does it do? How does summative assessment helps when it comes to assessment? It provides information and feedback that sums up the teaching and learning process. Let's just not study the definition of the terms, but let's see the importance, how it can be used, when it's used, so on and so forth. Like here we learn that summative is done at the end of the year or semester. You can give examples to that. And then, very important, it says it provides information and feedback that sums up the teaching and the learning process. Let's look at the examples of a summative assessment. Final or end of term examination, benchmark assessments, end of unit or chapter test, term papers, student evaluation of the course, and instructor self-evaluation. All these are examples of summative. All these are done when something is completed already, when the topic or when the course, the whole grade when it's done, or the whole term's work when it's done. You assess yourself on a summative, using a summative assessment. Next is the formative assessment. What is a formative assessment? We say it provides feedback. Like summative, it provides feedback and information. But this one is during the instructional process, not after, but during the instructional process while learning is taking place. Examples we have here is assessment done in class in a form of a test. Just a short topic, task, or investigation, that's a formative assessment. You are giving it during the learning process. Written classwork, assignments, project, and homework. All these are examples of formative assessment. Let's move on. Keeping an accurate record of learner performance is important. Keeping an accurate record. You give a record of all the learners' performance. Why is it so important to keep that record? There are so many different answers, more than what I've provided you with here. Stakeholders such as parents, other teachers, principal, education department officials, etc. may need to see a learner's progress. Maybe the learner is going through some challenging problems or whatever the child might be going through, and the child is referred for counseling. This counselor may require to see the child's performance. Is a child underperforming, or is a child, where does this child need assistance? So any stakeholder in any education department or any other officials may need to see the learner's progress. Therefore, it's very important to keep record of such. Next is to be able to determine whether the learner is ready to progress to the next stage of their schooling. For you to know if this child can make it to grade 9, for instance, or grade 3 or grade 7, this child has to be tested. The results has to be recorded. And by looking at the recorded performance of the child, that's when you'll be able to determine whether this child is ready for the next grade or so. So it helps us to determine the readiness of a child for the next stage of their education. Keeping accurate records is important to determine if and how intervention should be planned. Very important. You keep record. Later you realize, I assessed this topic, but this learner did not master my basic competencies. It takes you back for other interventions. You have to plan for the interventions. You must see how many needs compensatory classes in this topic or in this one. It's through the recorded performance that you'll be able to determine that. To allow for interlearner and interclass comparisons, you are trying to compare which class do you need to give more of your afternoons for assistance, for instance. You go back to their performance, you look at which class is behind or which one is performing below average. That's another importance of keeping record of the learner's performance. We move on. The 3 learning experiences that are necessary for teaching any topic in mathematics. Number 1, naturalistic learning experience. This type of learning experience is child-controlled. Child-control, take note. The child has control over their choice and action. That's what we mean by child control. The child has control over their choice and action. Children initiate this type of learning experience spontaneously as they explore their environment. During this type of learning experience, a child could begin to explore the concepts of addition and subtraction as they build and break down structures made of building blocks. So take note that naturalistic learning experience is child-controlled. Informal learning experience. Here, the adult initiates this type of learning experience. When the child is engaged in a naturalistic experience, these experiences are not pre-planned and occur when the adult feels that it is time to scaffold the child's learning. We move on. Lastly, adult-guided learning experience. With this learning experience, it's a type that pre-planned lesson or activity. meaning you have a pre-planned lesson or you have an activity. Here, meaning the adult guided learning. The adult is guiding. So you pre-plan something or an activity. This experience may follow the learning cycle sequence, or they may consist of more focused direct instruction. During this type of learning experience, an adult could give direct instructions, as we say, guiding, to a child using building blocks. For example, the adult could say to the child, add 3 blocks. How many blocks do we have altogether? You have given an instruction that the child must add. Later, you ask a question based on your instruction. So here the adult is guiding the child's learning experience. Now, guidelines for setting a test. These are just listed here, but one may be asked to explain them. I may say, explain the guidelines for setting a test. So we have various levels should be appropriate. The level of the questioning should be appropriate. Do not ask a grade 1 level question to a grade 4 learner. The lesson may become boring and very inappropriate and will not benefit such a child. That's what we mean by level should be appropriate for that test. Question types should be familiar. Ask things that children are familiar with. An example is to ask a child who have never been in an elevator and ask such a child, what would you do if you were stuck in an elevator? So give questions that are very familiar to the learner's environment. Language should be clear. Please, teachers, the language must be very clear so that you do not give misunderstandings or contribute to a child's poor performance. Mark allocation should be clear and must reflect time allocation. Do not give a 10-question mark for a 2-minute period, for instance. So your mark allocation and your time allocation, they should go together. Progress to more challenging question. Meaning, start with easy questions first, and then as you progress, you move on to challenging questions. This, if you give your learners a test, but you start with all the level 3 questions, all the difficult questions first, this may demoralize this child and may end up already having concluded that the test is difficult. So as the child answers, the child is just answering for the sake of answering and to submit the test. So start with something easy just to make it interesting for this child, or to proceed with concentration and not losing hope of the test, and the child end up not thinking to the best of their ability. That's what we mean by progress to more challenging questions. Check your test and memorandum. We are very prone to make mistakes. Sometimes we may overlook, it's human errors. So go back to your test, take your memorandum, check the two together. Next, difference between the justification approach and the telling approach. When you get to know this difference, be able to see which one is most applicable, which one is better than the other, and be able to explain it based on your understanding. Not just define justification, define telling approach. Be able to say this approach works best because of A, B, C. Okay, the difference is that the justification approach is an approach based on a constructivist theory of learning and teaching. Now, what is a constructive theory of learning and teaching? Constructive theorists propose that children are not empty vessels that are to be filled with knowledge and are rather active participants in the knowledge-forming process. The constructivist approach suggests that teachers should help learners to construct their own understanding of a concept, and that this understanding should be based on what children already know. Meaning, with the constructivist theory, we are building on what the learners already know. We don't take it that these kids have known nothing, they know nothing, they're empty vessels. No, they must know something from where they come from, even from their own home environments. They might have learned a few basics. So what you, in a constructivist theory, you now give them something that will add to their knowledge. Not something that you think, no, they don't know this, I'll not know. You test their knowledge, what they understand, what they already know. As a teacher, you must be able first to identify what do they know, at what stage are they, then build on what they already know. You are constructing Or let's look at the telling approach, if that's a constructive approach. Now, the telling approach, however, is an approach to teaching and learning. It assumes that learners learn best when they are given facts and then drilled on the facts that they've been given. You don't even test their existing knowledge. You assume they do not know that, and then you just give them facts, drill, for them to drill on those facts. Now, this is a telling approach. Learners are expected to memorize facts, and a large amount of the learning that takes place is rote learning. Meaning here there is no room for the kids to understand things, to be able to apply it in their own ways. They must memorize these facts. And then you give them a large amount of learning that takes place into rote learning. We will talk about rote learning later. In this type of approach, there's no individualized teaching, and the one-size-fits-all attitude is assumed. You assume that the whole classroom does not know what area is. You just drill them. This is a formula. You don't test them on their existing knowledge already regarding area. This is what we mean by there's no individualized teaching. It's you take the whole class as one, as what the other child knows, the other knows. If one does not know, the whole class does not know. Unlike the justification approach, where you first test their learners, the learners' existing knowledge, and be able to build on what they already know. That is a difference between the two. Let's move on. The common features that students must be taught in order to develop their classifying and logical skills. What are those common features? We have a long list. Color. Objects that are the same color go together. Example. We give an example. A group of blue counters and a group of your coloring objects. Remember here, we're trying to order things to be able to classify them logically. Now, shape. Objects of the same shape go together. Example, a group of round objects and a group of square objects. You are ordering, grouping to be able to classify. You put all the round objects together, all the square objects together. That's what we mean by that. Size. Objects are grouped according to their size. We move on. Material. Some are soft, wooden, plastic, paper, and so on. Pattern. Pattern can be plain objects or group of spotted objects. There must be a pattern how we are grouping such objects. We have texture. Objects grouped according to what they feel, like hard objects or soft objects, like that, or rough or smooth. We are describing or grouping them, or we are classifying them according to how they feel. We have functions. Objects are grouped according to their uses. So meaning you can group objects according to their uses, their functions. A pen and a pencil, they are grouped because they are used for what? For writing. And then we have a pot and a stove, they are grouped for what? For cooking. And then we have a shoe and a shorty. They are used for what? For clothing or for dressing. So we are grouping things according to their own functions. And then we have association. Objects are grouped as they serve a common function or are associated with a common phenomenon. Example, a tiger, a lion, and a bear are all found at the zoo. And then we have a trolley or a cash register and a cashier. Where are they found? They are all found in the supermarket. So that is how we group different things. And then we have class name. Objects are grouped according to their class of objects to which they belong to. Example, a dog, a cat, and a rabbit. What are they? They are animals. And then we have bread, jam, and rice. What are they? They are food. So according to class name, we can also group or classify objects. Then we have common features. Objects are grouped according to a physical attribute that is common. Example, dogs, cats, lions, and horses they all have 4 legs. And then you can say fish. You can have fish. You can have anything from the sea. Anything from the sea. Then you can group things that have the common features. Where do they live? These ones you can say they all have 4 legs. And then these ones you say they only have 2 legs. Or you say these ones can talk. You can find things that they have the common features that they can be grouped as one family. We have number. Objects are grouped according to how many objects there are in each group. For example, pictures depicting pairs are grouped and pictures depicting single objects are grouped. So we group things according to so many different features. So objects, that's how you classify them. Let's look at the patterns. We have two types of patterns here. There can be three in numbers. But here I provided you with two patterns, the simple patterns and the number patterns. There's also a natural pattern, please take note. So simple patterns, they involve repeating shapes or objects. Simple patterns involve repeating shapes or objects. Meaning, square, triangle, circle, square, triangle, circle. You are repeating, it's a pattern of shapes, but they have to be in order. If you started with a square, when you are done with the first set, start with a square again. Number patterns, patterns where there is constant relationship between each number in the pattern. For example, 2, 4, 6, 8, 10, 12. The pattern is, what is the pattern in this number pattern? You add 2 to each number to get to the following number. That is the pattern. That's how you get to the next number. Now we have money-based activities. And here it says 3 money basics that you can use in your classroom to develop learning of measurement with money for pre-primary and primary learners. Meaning, how can you teach this concept to learner? Money-based activity. But take note, we are talking of pre-primary and primary learners. You have comparing prices. You can talk about comparing prices. Having children to compare prices can be done in and out of class or school setting, where children compare prices at local shops or in the shop. Simulation in the classroom. As a teacher now, could turn different sections of your classroom into different shops and price certain items in each shop. After children have explored the different shops, you can lead a discussion as to which shop were the cheapest and whether all the items at that shop were the cheapest. An alternative activity is asking students to compare the prices of different sizes of packets of the same object. Take note, pre-primary learner, most of them are not sent to shops to go do shopping. Most of them are not trusted with money. So you as a teacher, you can already introduce this concept to the learners in the classrooms. Divide your classroom into different corners. This is Edgar's, Foshini, Truoth. And then in each you put small items, price them, different prices. And then you play around that. It's kids are taking part, they are involved. But at the end of the day, the most important, they are learning money, how to compare prices, what is cheaper, what is expensive, so on and so forth. Next one, we have wages or salaries. For younger children, you could arrange a series of jobs that need to be done around the classroom in order for them to earn their wages. Have a teacher, a principal, an HOD, have a doctor, a nurse, have a lawyer in the class. And then you tell them, your salary is this much, your salary is this much. They are playing around their salary. They will know, I am earning more than who is earning more than who. They are learning what salary is, what job. You understand, these are small children, but they need to understand these concepts already. Before they start calculating salaries, they must already know that, okay, salary is what you earn when you do this type of job. So on and so on. Okay, we move on to currency. In introducing currency activities, simple conversions can be used. For example, double or triple. Remember, these are only small, tiny ones. So you use terminologies like double or you triple. As children's numerical proficiency increases, more complicated currency exchange calculations can be introduced. So for now, you can just use double or triple. You are introducing the currency activities in very, very simple conversions for them. Just not to make them hate mathematics or hate them, make them hate school because of that. So use very simple conversions for them to understand already, just by using words like double or triple. Not to compare the currency for which country and which, no, that one will be too much for them. It will be too much of a challenging activity for them. Lastly, we have budgets. Younger children could budget for a few items. For example, you could tell children that they have $10 and that they are going to go to a shop. At the shop, they sell chocolates for $2, sweets for $1, and cool drink for $3. Children can then spend the money as they wish. So you are teaching them how to budget, that you only have a $10, but in this shop that you go, you will find things that cost more than $10. So you are now teaching the child that use within your budget, within what you have. So those are a few activities that you can apply in your classrooms when it comes to money-based activities. Let's move on to the next topic, guidelines for planning outdoor learning activities. What are the guidelines? As a teacher, you are planning an outdoor learning activity, for instance. So what are the guidelines that you have to put into consideration? Number one, prepare learners before taking them outside. They should know what they are going to be doing, how you expect them to behave. Otherwise, they will go out there, they'll start doing things that are not part of your lesson preparation, that are not your lesson preparation. So inform them, talk to them, prepare them before they go outside there, so that they should know what they expect from you. Plan your lesson. Decide beforehand what mathematical concepts you want children to explore, and plan how you will guide this learning. Not just to go out for fun. They must learn something. So have that on paper, that at the end of Maado, I want this and this to be achieved. Next, decide how you will evaluate learners' learning. Then we have flexibility. Be flexible. Even a well-planned activity can go wrong in reality. Adjust your activity, and you can reflect later on better ways to execute the activity the next time. So you have to be very flexible, that if this happens this way, you should be flexible enough to do plan B. Then lastly, we have creating links between context. Link what children have learned in the classroom to what you want them to learn outside. When you return to the classroom, link your teaching to what children learned outside the classroom. So there must be a link between what they did outside to what they learned inside the classroom. We move on. We have two common conceptual difficulties that learners might have when learning to work with decimals. What are these difficulties that learners experience when dealing with decimal numbers? Number one, misunderstanding the decimal point. Many children do not realize that the decimal point separates whole numbers and parts of a whole number. Children often interpret the numbers after the decimal point as whole numbers instead of numbers less than 1. For example, in 0.54, the learner thinks that the 54 represents 54 whole units, not knowing that it's less than 1. It's a decimal number. So those are the misunderstandings regarding decimal point. Now, the next one is transferring whole number properties to decimal. Often, whole number properties relating to magnitude are incorrectly to decimal. Learners believe that the longer the number is, the larger it is. For example, a learner will interpret 0.545 as larger than 0.8 and 0.50 as larger than 4.5, which is not the case. So learners have this misunderstanding. They think when you are transferring that number, this transferring of the whole number property thing, if you give them 0.999 and you give them 0.9, they will tell you that 0.999 is larger than 0.9. So we need to go around as to how to avoid learners doing these mistakes, as to how we can help them overcome this difficulty. The differences between a physiological and a psychological mathematical learning difficulties. I do not know why students confuse the two, physio and psycho. Just those two words already. Physio, physical, it's leading to physical, and psychological has to do with mental. So let's look at our definitions here, or the difference here. It says a physiological learning difficulty is a learning difficulty that is caused by physical ailment or physical damage, such as brain damage. It's physical. Now, this brain damage causes mathematical learning difficulty because the child will end up seeing or thinking difficulty in just even addition, just to add up. It's because to that physical brain damage. So that's what we mean here. An example of this type of mathematical learning difficulty could be a child who is colorblind. Colorblind is a physical ailment and may have difficulty in carrying out tasks that require the use of color. For example, color in all the blocks that have an answer of 10 in blue. This child is colorblind. Blue for this child is black. The child only sees black. Any dark color is black. Any bright color is white. So because of this physical ailment or this physical ailment that this child has, it leads to that learning difficulty because the child will end up getting answers wrong. And what are the causes? It's this color blind that the child has. However, on the other hand, a psychological learning difficulty is a difficulty that is caused by a psychological blockage, such as a behavioral or cognitive problem. An example of this type of mathematical learning difficulty could be a child who is having trouble remembering his timetables, or a child who has trouble knowing where to start when solving a word problem. These ones are the most difficult ones to really teach, let me say. So one has to study the whole concept as to how to go about how to help a child with a psychological learning difficulty. This child may end up swapping letters. 9 as a 6 will end up seeing as a 9 as a 6, or will end up calculating instead of starting from the left, the child will start from, all these things. It's psychological. There's a cognitive problem somewhere there. So this is the difference between the two and the examples as to what is a psychological learning difficulty. A child won't even remember the timetable. You would say, study a table of 2 up to 5, for instance. The child will have difficulties. This is a psychological learning difficulty. Next one, the mathematical learning difficulties and the common causes of such difficulties. We have 4 mathematical learning difficulties. Number 1, the memory problems. A child has problems with remembering of facts such as recalling names of numbers and symbols, or how to set out their sums. That is a memory problem. Now, this is caused by a child's general slow development of memory techniques, or possibly because a child does not understand what they are doing, and therefore they are trying to remember. Does not make any sense. Them trying to remember does not make any sense to them, making it more difficult to recall. Because the development of this child is so slow, the general development is very, very slow. Therefore, even just remembering the numbers of the names, the child cannot recall at all. This is a memory problem. Procedural problems. A child will have problems carrying out procedures. They also have difficulty knowing how to start sums or remembering the steps of the procedures. These are procedural problems. Procedural problems may be due to slower cognitive development, where a child has not yet cognitively mastered skills such as multi-step thinking in a mathematics context. Visuospatial problems have difficulty with spatial relation. They may have difficulty writing numbers and symbols and misalign numbers in columns. Problems with writing numbers and aligning sums are often a developmental delay problem, where children may have difficulties in either associating a number with a symbol. They do not know that the 3 represents 3 objects. Or with writing the symbols correctly, they may write A, E facing the other side instead of a 3. You understand? Number 4, problem-solving difficulties. Children may not know how to identify the type of problem and may have trouble deciding where to start when attempting to solve a problem. Just to solve, they may not even know. They may not even be able just to know how to identify the type of problem that they have. You give them a problem that requires BODMAS method. They will not know that here I need BODMAS to solve this. You understand? It's like it's problem-solving difficulty. They don't know how to solve problems, where to start solving such problems. Problem-solving difficulties are similar causes to procedural problems. Children most likely experience problems with problem-solving activities because they are unsure of what is being asked, or because they do not know the steps that should be taken to solve a particular type of problems. Word problems can prove especially difficult for some children, as they require children to interpret written as well as numerical text. Word problems, they must read, relate what they are reading to solve it in numbers, in numerical text. These problems, this type of word problems will be very much of a challenge to learners having a problem-solving difficulty. Okay, we move on to the importance of understanding of the learning cycle as a framework for curriculum development and classroom teaching. Number 1, an understanding of the learning cycle is important for curriculum development and classroom teaching because when planning teaching activities, it is important to understand how children learn. With an understanding of the stages that children go through as they learn, an effective curriculum planner or teacher can plan activities to reflect the natural stages that children go through when they learn something new. Remember those stages. By aligning teaching with the natural way in which children learn, school is less of a foreign environment for children and learning is facilitated. Children are less likely to have difficulties with a topic if they have gone through all the stages of the learning cycle when being introduced to that specific topic. Skipping stages can be detrimental to children's learning, and curriculum planners and teachers need to have a good understanding of the learning cycle. Okay, next we have adult guided learning activities you could use in a lesson on measuring temperature. Remember, measuring temperature, and adult must guide this. As a teacher, you have to be there to observe and to guide the learners. So this is just some of the lesson activities that one as a teacher can use when it comes to the topic of measuring temperature. Create a weather chart and discuss the temperature every day. That is one. Bring ice blocks to school and have children record their melting times on a cold day and on a hot day, or in a glass of cold water and a glass of hot water. Bring a thermometer to school and measure the temperature of differently heated cups of water. For example, hot water in one, room temperature in one, room temperature in the other, and fridge water in the other. We have different heated cups of water, hot water in one cup, room temperature in the other cup, and then fridge water in the other cup. The learners now, they have to feel they are now measuring the temperature in those cups. By feeling, is it hot, cold, normal? You understand? If you do not have a thermometer, you could ask children how they could tell the temperature of each, touching the cup, feeling the water, testing the water. So you have taught them temperature by, you improvise. If you don't have the thermometer, or your children are too young to understand reading off from the thermometer, teach them temperature by feeling it, by tasting it, by touching it. So that's some of the activities that you can play around when it comes to temperature to a pre-primary learner. Now, how to make homework an effective means of assessment? There are various and lots of ways as to how to make homework an effective means of assessment. Manage the difficulty level. Homework needs to be set at an appropriate level. Homework should consist of mostly average questions with a few easy and a few challenging questions. If questions are too easy, learners will get bored and will expect their assessment to be at the same low level. If questions are too difficult, learners will become discouraged and may give up, as I said earlier. Collect or check homework. It is important to collect and check or mark learners' homework. If homework is not checked, you will not know if learners are able to do the homework, and learners will not be incentivized to do the homework. Remember, if you just give homework, you don't check it, you don't collect it from them. The end of the day, learners will know it's a culture. You just do it and the teachers doesn't mark it. You find learners who will not even do the homework. And apart from that, it's just part of a teacher's job to mark that homework, assist the learner where the learner have gone wrong. It's the easiest way to identify where the learner needs your help as a teacher. It's through checking their homework. Keep record of the homework. If the homework is not done every day, take note. Parents meeting, inform the parents that this child doesn't, please help your child, make sure the child's homework is done. And it also helps you be able to know where to assist this child when you go through and you see, oh, but this topic, this child failed most of the homework, got wrongs on this topic, and this one, this child, you'll be able to know where and how to assist, how to go about when it comes to compensatory lessons for this particular child. Next, it is important to keep a record of homework progress for your class. This could involve recording that learners do not do their homework and which learners are consistently having problems getting their homework correct. This record can be used to plan early interventions so that learners can work on areas they are having problems with before test and exam. As I said, the record, helps you as a teacher plan early for your interventions as to how to go about helping these children. Vary homework activities. Setting list of sums every day can make homework become a tiresome chore for learners. Homework activities should vary. Sometimes an exercise of problems is necessary, but other times ask learners to do something more practical, such as measuring, collecting data, or collecting materials for model building. Homework should also not be too lengthy and should not be given every day. Never give homework for the sake of giving homework. Please, it becomes tiresome for the children. Do it for the learning process, for the benefit of the child. Now, students, this presentation should not be seen as a guideline only. Do not limit your chances of excelling in this module by studying the above points only. Gather as much information as possible. You have study guides, you have your student portals. Please make use of all your resources very well for your exam preparations. If you experience any problem regarding this content, feel free to contact me on 081-3041-340 between 6 and 8 every weekday, and on weekends, make it anytime, Sundays only after 1. So I wish you all the best for your examinations. Preparation should start now. Study the content very well. Do not memorize. Please show your understanding in answering all your questions.